Okay, so here's some fill in the blanks. Okay, now I have my y equals x squared, my quadratic. This is basically the basic, oops, basic quadratic function. Okay, you must know how to draw this very well and quickly, this quadratic function. And that previous video with the first differences showed you basically the steps. So let's go over this. This shape is called what is this shape called right here? This shape is called a parabola. When we talk about the vertex, every parabola has a vertex, and every quadratic equation has a vertex. In this case, the vertex is this edge right there. The vertex is, in this case, it's 0, 0. The function is symmetrical about a vertical axis. What does that mean? That means it's symmetrical around some axis, and the axis is right here. And this point, this line, is called x equals 0. Okay? There is a pattern on the first difference called we call it a step pattern. That's this. That's how we take our steps. 1, 3, 5. And every parabola will have a step pattern. The second differences are constant. What's this word refer to? The fact that second difference doesn't change. This is true for every quadratic equation. This must take place for the function to be quadratic. So all of these must be true in order for a function to be quadratic. All these are characteristics of a quadratic equation or function. Here's a new quadratic function. I have the same thing except I have a plus 3. So let's look at it. Okay, so if we actually want to draw it by points, we can say that at x equals, well, we already solved it. I already have it solved here. But when x equals 0, y equals 0 squared plus 3. Y equals 3. That's why we have 3 right there. And we basically substitute all these values in. When x equals 1, let's just do x equals minus 1 as well. Y equals 1 squared plus 3, which is equal to 4. So I have another point, 1, 4. Let's look at this. When x equals minus 1, y equals minus 1 squared plus 3, which is equal to 1 plus 3, which is equal to 4. My next point is minus 1, 4. Do you see how they're symmetric? Whoops. When x is equal to 2 and x is equal to minus 2, let's just do this together. Y equals, when x equals 2, y equals 2 squared plus 3. When y equals minus 2, y equals minus 2 squared plus 3. It's going to end up being the same thing. 2 squared is 4, plus 3 is 7. Here's the case here too. 7. Now, finding all these points is a lot of work. That's why I taught you the step pattern earlier. The point is to find the vertex. Let's graph this. Let's just solve all these points, okay? 3 squared is 9, plus 3 is 12, etc., etc. Once we graph all these points, it's going to take a lot of work. We're going to look at our first difference. By the way, it happens to be the same. This is how we're taking it. 19 minus 12 is 7. 12 minus 7 is 5. 7 minus 4 is 3. 4 minus 3 is 1. 3 minus 4 is minus 1, etc., etc. And we see our step pattern is the same. 1, 3, 5, 7, just like in our previous example. Our second difference is going to be 2. That's going to be true for all our quadratic functions. So our steps increase by 2. Oh, it's drawn out here. There we go, it's drawn out. These are my points. 0, 3, 0, 3, 1, 4, and 1 minus, and minus 1, 4. That's here. 2, 7, and minus 2, 7, minus 2, 7. And basically this is our quadratic function. This is exactly like y equals x squared, except it's moved up. We've moved the vertex 1, 2, 3. This is consistent with a general rule that we have that we're going to see later. Okay? If we found it by points, which is what we did, we basically substituted our x values, found our y values, and plotted our points. But the easier way would have been to find the vertex. Has to be a way to find the vertex. And now we have a step pattern. My next point is going to be 1 step, 3 steps, 5 steps in both directions. 1, 3, 5. And now we have a quick way to draw our parabola.